Alright, so I'm going to talk about the graphing lines and points and planes. So this is all going to be about graphing. Alright, so right now we're going to be only dealing with the Cartesian coordinates. And it's also considered rectangular coordinates. This is the main one you're going to use for a very long time until you get some more complicated problems. But what this basically says is this is y, this is x, and you take a point xy, and you could graph it anywhere on this graph. So let's say I have 3, 1. So that means that x is 3, so you go 1, 2, 3, and y is 1. So that intercepts right here. That's where the point is. And the reason why it's rectangular coordinates is because you go over 3, up 1, or up 1 over 3, and you form like little rectangles, where the point right here is your position. So you basically form, like if I'm running here, it'll be one big rectangle, whereas this much x and this much y. And that's how you graph this, by creating like little rectangles. Okay. So I should talk about how to use these points in graphs. So we have two different types of graphs. Two different types of way to graph. We have point slope form. Slope intercept form, sorry. So slope intercept form is basically this equation right here, where this is the y-intercept and this is the slope. Now, how does this work? So there's two ways to graph something. You either graph it through two ways to graph it through intercepts, or through the slope intercept form, or by using slope, in other words. So we shall graph using intercepts first. Alright, so if I have an equation y equals 3x plus 1, the way intercepts work is that all you need is 2 points to make a line, because you just need to know where the line's going. So all you need is 2 points. If I graph right here and I do one right here, we can make a line easily. So what intercept does is that we can get a point on the y-axis, on the x-axis, and that way we get a line. And that's the two easiest points to get. Now how do we do that? Well, remember that this is x is 1, x is 2, x is 3, x is 4, x is 5, x is 6, x is 7. Right here, x is 0. So all along this line right here, x is equal to 0. This entire line right here, x is 0. So when we say x is 0, we plug this in and we get y equals 3 times 0 plus 1, so y equals 1. So when x is 0, y is 1 right here. Whoops. If I do like this, y is 1, x is 0, this is the point. Okay, I'm going to try and clean this up because it looks a little messy. Okay, now what about this line right here? Well, just like x, this is y is 1, y is 2, y is 3, y is 4, y is negative 1, y is negative 2, y is negative 3. So this line right here is when y is 0. So we shall do that. When y is 0, for this graph, we get 0 equals 3x plus 1. Move one other side. We solve for x, and we get divided by 3, negative 1 over 3. That means that x is negative 1 over 3 right here, and that's our graph. Boom. And all you do is do the intercepts. Y0, x is 0, and you find where it is in this graph. Now, I shall graph using the other method, which is alright, slope-intercept form. So this is it right here. Y equals mx plus b, where b is the y-intercept, and mx is the slope. So when I have y equals 3x plus 1, 1 is y-intercept, so I could pop 1 right at y. Boom. Right here, y is 1. Because this is b, and b is where it intercepts on the y-axis. So I'm going to try to make this look a little prettier. Make it look a little prettier. Doom, doom. So, y-intercept. So this is y-intercept. So y1 goes right here. It intercepts that y-axis at 1. Boom. And this is y, this is x. Now this is the slope. And the slope is rise over run. So what that means is 3x is equal to 3 over 1 x. Which makes sense because everything's over 1. So 3x is 3 over 1x. So this is rise over run. So you rise 3 and you run 1. So rise 3, 1, 2, 3, go over 1. Rise 3, 1, 2, 3, go over 1. So if you graph this, it looks something like that. Which is basically the same graph we got for intercepts. So there's one more method that we can use for graphing. And we have this other one called the point slope form. Which is y minus y1 equals the slope x minus x1. Now, why is this? What is the advantage of using this over slope-intercept form? Slope-intercept form, point slope form. What is the advantage? Well, with point slope form, you could get any x and y and its slope, and you could turn that into slope-intercept form. So basically, point slope form helps go from this to this. For example, get rid of this, move this up, and move this up. Alright. Excuse me. So, this is the point intercept, and this is the point slope. Sorry, this is slope intercept form. Slope intercept. This is a point slope. So, how will we use this? Well, let's say that we have an equation of a line that passes through the points -1, 2. And has a slope of -2. What's the graph of this in slope-intercept form? Well, looking at this, we could say, okay, well, this is x and this is y. We're going to call it x1, y1, just to put in this equation. So, if we follow this equation, we have y minus y1, which is 2, equals the slope, which is -2, times x minus x1, which is -1. Now, x minus a -1, that's plus. Minus minus is plus. So you get y minus 2 equals negative 2, x plus 1, and we shall distribute. So we distribute the 2 to each term, so you get y minus 2 equals 2x plus 2, and you get x on y by itself. You add 2 on both sides, so plus 2, these cancel, and you get y equals 2x plus 4, and this is your equation. Now notice how when you distribute and move everything on the other side and you get y by itself, you end up with this form, y equals mx plus b, where b is equal to 4 and mx is 2x. So that's how you go from just a point and a slope, which is why it's called point slope form, to get slope intercept form, which is this. Now, one more thing I want to talk about is 2 points. Alright, almost. Alright. So what about finding a graph with 2 points? Where it's like 3, 1 and 4, 2. I hope these numbers work out. It's just kind of random. There's just a list. So we have 0.3, 1, and 4, 2. What is the graph look like? So if you have a graph like this, so you have 3, 2, 3, 1, and you have 4, 2. Whoops. What is this graph? Okay. So the best way to do this is, first, we have to assign we're going to call this y1, x1, y1, x2, y2. Okay. When you assign these x1, y1, x2, y2, a lot of people get confused because they don't know, okay, so which one's x1, which one's x2, which one's y1, which one's y2. As long as you keep them paired up, x1, y1, and x2, y2, it doesn't matter. So I could call this one x1, y1, and this one x2, y2. The order does not matter at all. Okay. So we have this. Only piece we're missing is the slope. And we have a formula for slope, where the slope is equal to the y2 minus y1 over x2 minus x1. Which basically says, in a nutshell, you go from here to here, you have the change in y, and you have the change in y from here to here. So this is y1, y2, and you have the change in x. So in order to get to this point right here, from here, you have to change y and change x to get there, which is what the slope says. The change in x and the change in y. So we take out y2, just 2. So we get m equals 2 minus, and the y1, which is 1, 2 minus 1, over x2, which is 4, minus 3, and you get 2 minus 1 is 1, over 4 minus 3 is 1. So the slope is 1. Oops. Slope equals 1. You could also go the other way, where I'll go the other way also, just to show you that it doesn't matter. So let's pretend that this is x2, y2, and this is x1, y1. Just to show you that it doesn't matter. The order does not matter at all, as long as you keep them paired up. So y2 is 1, minus y1 is 2, over x2 is 3, x1 is 4, and you get 1 minus 2 is negative 1, over x minus 4 is negative 1, and negative 1 over negative 1 is equal to 1. Multiply or divide negatives, you get the same, you get positive. Okay, so to finish up this video, now that we know the slope is 1, I'm going to put it all into point slope form, and then come out with the slope intercept form. So, point slope form says y minus y1 x1. So remember that I changed this. Well, actually, it doesn't really matter. It doesn't matter. Okay, so I'm going to pick the y1, which is this 2, equals the slope 1 times x minus x1, which is 4. And I could do the same thing with this one. It doesn't matter. So you get y minus 2 equals x minus 4. So y equals plus 2 plus 2. These cancel, and you get x minus 2. And this is the graph. This is the line that goes through these 2 points. And this is in y equals mx plus b form. So this is the b, which is the y-intercept. And this is the slope, which is mx, which is 1x. Which you can also say x. Alright, that's a basic video over graphing, simple graphing, and plotting points.